Okay, let's look at some examples from the 3.3 homework. First one I want to start with is number 3. This one has you investing P naught, so some initial amount in a savings account in which the interest is compounded continuously. Remember, this means that I can use base E because base E represents continuous exponential growth or decay. At 6.8% per year, that is, the balance P grows at the rate given by the following equation. So take a look at this equation. This is important because it's written in that same form that we saw in the concept video. What does that tell me? That means this qualifies as exponential. So when I look at part A where it says, okay, find the function that satisfies the equation, what type of function am I writing? I'm writing an exponential function. And I'm going to write it in terms of P naught and this 0.068. What is that 0.068? That is the interest rate. So let's write my equation. P of t, that represents my output or my function value, is going to equal, instead of n naught, I'm going to have P naught because it's the principal amount that I invested. Since it's compounding continuously, I'm going to have base E. What's my growth rate? My growth rate is just that 0.068, and that's multiplied by time. I don't have a set amount of time, but that's okay because time is my independent variable. That's where I can plug things in. Okay, so part B. Suppose that $1,000 is invested. What is the balance after 3 years? So what are each of these pieces? Let's make sure we understand each of these pieces. What is this 1,000? Since I'm investing that 1,000, that represents my initial amount invested, and that is P naught. And then what's the balance after 3 years? That's my independent variable, so that's what I plug in for t. I get P of t. 1,000 is my P naught, E to the 0.068 times 3. And from here, this is just calculation. You can just use your calculator to actually figure out what this value is. When I plug E to the 0.068 times 3 into my calculator, I get 1.22629815535. I want to keep as many decimal places as I can throughout the calculation, and I'll round at the end. And so then I'm just going to multiply that by 1,000, and I get P of 3 is equal to 1,226. And since this is talking about money, I'm going to round to the nearest hundredth, so I get 298, but then I'm just going to round that to 0.30. So that's the amount that's in this account after 3 years. That's the balance of the account. Look at part C. Part C is asking, when will this investment of $1,000 double itself? Well, what is that really asking for? It's asking for the doubling time. And it's interesting because this question specifically says the 1,000, but remember, what did we learn about doubling time? Doubling time is the same regardless of what you start with. So for that doubling time, I just need to use that formula of ours where doubling time is just equal to the natural log of 2 divided by k. It doesn't depend on that initial value. There's nowhere for me to plug in the 1,000. It just depends on my growth rate. So in our case, it's just natural log of 2 over 0.068. I can plug that into my calculator, and I get about 10.19, rounding to the nearest hundredth. What does that mean? It means it takes about 10 years for the value of this account to double. But that takes care of number 3. Okay, next one. Let's look at number 6. And this one's pretty similar. We're still going to be modeling the equation using an exponential function. Everything here is in terms of trillions. And so just keep that in mind as we work through this. So in 2011, a country's federal receipts totaled 2.15 trillion. So that was in 2011. In 2013, the receipts were 2.76 trillion. If we assume that the growth of federal receipts can be modeled by an exponential function, so perfect, that means I can just use that equation that we've been using for all the other problems. And if we use 2011 as the base year, first we have to find the growth rate k. So that's part A. Let's find the growth rate k to 6 decimal places so that we can write my exponential function f of t for the total receipts. Well, what if I were to try writing it right now? N is equal to n naught e to the kt. I don't know k, but do I know the initial value? Do I know n naught? If we assume 2011 is my starting point, then yes, N naught is 2.15. Remember, this is all going to be in terms of trillions of dollars. And then e to the kt. I don't know k, but what do I know? I know that 2 years later, in 2013, the receipts were 2.76 trillion. So how can I use that? I can use that by plugging in 2 for t. If I plug in 2 for t, that represents 2 years have passed. What should my ending value be? What should my function value be? That should be 2.76. So I get 2.76 is equal to 2.15 e to the k times 2. And now I have an equation with only one variable, and therefore I can go ahead and solve this. I'll go and divide by 2.15. I get 1.28372. I'm going to stop there because my next digit's a 0, equals e to the 2k. Once again, how do I solve for a variable in the exponent? This is where I'm going to pull out my natural log again. So I'm going to natural log that, and I'm going to natural log that. Natural log of 1.28372, that requires a calculator. But over on the other side, the natural log and the e cancel. And I'm left with just 2k. So if I finish solving for this, I get k is equal to the natural log of 1.28372 divided by 2. And I get k is equal to, and this is where try and round as little as possible because it wants it to 6 decimal places. So you want this to be as accurate as possible. So in my case, I got 0.124881. The next digit's a 4, so I'm not going to round it up. I'm just going to keep it as a 1. So there it is to 6 decimal places. So now that I have k, I can come back up here and rewrite my equation. N naught is 2.15 e to the, and then my k is 0.124881 times t. And there's my equation. And I'm done with part A. Part B. Part B is just saying, well, let's estimate the total federal receipts in 2015. Now that I have an equation for this, this becomes much simpler. The only tricky part about it is recognizing, what do I plug in for t? Am I going to plug in 2015? No, you're going to get an absolutely massive number that's way too big. By plugging in 2015, you're assuming that 2.15 represents the year 0, which of course it doesn't. It represents the year 2011. So instead, what do I plug in? 2015 represents 4 years after 2011. So you're plugging in t equals 4. So you're going to get n equals 2.15 e to the 0.124881 times 4. And then once again, that's just something you throw into your calculator. Then I get n equals 3.54306383321. Now, this is where it gets a little bit tricky because once again, we have to remember this is in terms of trillions of dollars. And so when you enter in your answer, just be careful to read how they want you to enter it in. It might ask for the amount rounded to the nearest 1,000 or something like that. And that's where, so you just be careful. If this is trillions, then that means I move the decimal place how many times? 3 to get it to the millions, 3 more to get it to the thousands. Quick little edit here, I forgot billions. So when I'm converting this to just regular money values, if this is trillions, I'm going to move it 3 times to get it to the billions. So there's billions. Move it 3 more times to get it to the millions, 3 more times to get it to the thousands, and then 3 more times to get it to the regular dollar value. So instead of this being my value, I'm going to put another comma in here, 100, and that's the total federal receipts. That's actually trillions of dollars, not billions of dollars, which I had before. Okay, so part C. When will total federal receipts be 15 trillion? So right from the get-go, hopefully we can recognize what it's asking for. What am I going to be solving for in this problem? I'm going to be solving for t because it's asked that question when. I'm solving for a t value. So where do I put this 15 trillion? That represents my output value. So I'm going to put that in for n. It's my output value. And then t represents my unknown, and that's what I'm going to be solving for. I'm going to solve this pretty much exactly how I solved this first piece. I'm going to start by dividing by 2.15. I'm going to take the natural log of both sides, and then I'll divide by my growth rate. And I get 15.555, so just 15.6. I'll round that up to the nearest tenth. Once again, that's another thing where just be careful of what it asks for and round to the appropriate value. But what this means is it takes about 15 and a half years for the federal receipts to reach 15 trillion. Okay, but those are the examples that I wanted to go through. If you have questions on any of the other problems, please feel free to shoot me an email. But good luck with the rest of the assignment, and we'll see you in the next video.